Hello friends, welcome to the YouTube channel Saurav Kumar in Physics, and in today's topic we are going to discuss, as you can see on our board, Introduction to Trigonometry. As you know, trigonometry derives its root from Indian culture. Yes, you have heard it right, it's from Indian culture. You can see here, Trigon. Trigon means in Sanskrit, Trigon means triangle. And in today's video, as you have already guessed, we are going to discuss some basic concepts of triangle, and you have to start learning it from 10th class. From 10th class you can use it in 11th, and you can even use it in 12th. But this helps you in lifetime, because trigonometry is a topic with which, if you are pursuing in your medical career, non-medical career, or if you are opting commerce with maths, you can find the distances of very far away places easily. And so in today's video, I am going to discuss with you some basic concepts. As you can see, introduction. In this video, I am going to introduce you to this topic, and I'll discuss some important tips. So before I proceed, please subscribe our channel Saurav Kumar in Physics, and after that, please press the bell icon. Before we proceed, let me tell you about an important quote. This quotation was said by J.F. Herbert, a famous mathematician of his time. He said there is nothing that occupies so much middle space in mathematics as much as trigonometry, which means that he meant to say that the most important topic in maths is trigonometry. And yes, it is, because from an examination point of view, especially for 10th class, at least 15 marks are based on your trigonometric questions. It means that giving your board paper, at least 2 questions of 4 marks will come from the chapter of trigonometry itself. In short form, as you know, we call trigonometry trigo. So for making it easier, I call trigonometry trigo. And as you can see on our board, I have drawn a right angle triangle ABC, and I have made the angle at A. So let me just call angle A theta. I suppose that angle A is theta. So we are going to now discuss about the 6 trigonometric ratios, and the 6 trigonometric ratios are sine, cosine, tangent, cosecant, secant, and cotangent. The short forms, as I tell you, is for cosine, it's sine, sin. Cosine, we call it cos. Tangent, we call it tan. Cotangent, we call it cot. Cosecant, we call it cosec, and secant is called sec. So as we are discussing about the 6 trigonometric ratios, so first ratio, which we call it as sine, we write it as sine, S-I-N. Sine means the ratio of a triangle. Suppose we have A as theta, the ratio of perpendicular upon base. Perpendicular are in this sense refers to the side that is opposite to our angle. So since in this angle we have taken A as our theta, so our side will be BC. So sine theta, or else you can say sine A, equals to BC upon AC. In simple language, if you want me to define it, I'll define it as sine of an angle. Sine of an angle is a ratio of its perpendicular and its hypotenuse. In this triangle ABC, where we take A as theta, we have our perpendicular as BC, and our hypotenuse, as you already know, that in a right angle triangle, any side in front of our right angle is called the hypotenuse. So in this, we have AC as the hypotenuse. So our value of sine A will be BC upon AC. And moving on to our next trigonometric ratio, which is cos. Similarly, we have cos A. Cos A. Now, cos A, what do you mean by cos A? Cos A refers to the ratio of the base of the right angle triangle with its hypotenuse. Now, in this triangle, where we have taken A as our theta, our base will be AB. So cos A becomes AB divided by AC. Similarly, now if we want the value of tan of angle A, tangent, full form tangent of angle A, tan A. Now tan A of a right angle triangle is a ratio of its perpendicular by the base. It will be written as P by B, perpendicular by base. So tan A for in this case of this triangle will be BC by AB. Now these three are our main trigonometric functions upon which our other three depend. The other three, which is called as cosec, I am writing it out here. Cosec A. Cosec of an angle is the reciprocal of its sine. Sine we have out here is, you can write it as cosec A is equal to 1 by sine A. Sine A we have BC by AC. So our cosec will become AC by BC. This is the value of our cosec. Then similarly we have sec. Sec is the reciprocal of cos. We have cos is equal to AB by AC. Then our sec is equal to sec A will be 1 by cos A, which means cos A, AB upon AC. Then sec A will be AC upon AB. And finally we have cot. Cot you can say is the reciprocal of tan. So our value of cot A will be 1 by tan A. Cot A will be, since we have tan A BC by AB, cot A will be reciprocal. So our cot A will be AB upon BC. So these will be our 6 trigonometric ratios, you can say. Tan A, I am going to again repeat all the values. Sin A is equal to perpendicular upon hypotenuse. Cos A is equal to base upon hypotenuse. Tan A is equal to perpendicular upon base. And cosec A is equal to hypotenuse upon perpendicular, the reciprocal of sin A. Then sec A is equal to hypotenuse upon base, the reciprocal of cos. And cot is equal to base upon perpendicular, which is the reciprocal of tan. These are our 6 trigonometric functions. And in these 6 trigonometric functions, each one has its own importance, its own value. And as I will give you a fact, which means a bit of knowledge, as you might already know, these functions was first discovered by the great Indian mathematician Aryabhatta. He was the first one to derive the values of sine of some angles, and I am going to discuss that angle further. So please note this down, then I will discuss further. Now before moving on further, I'll give you a small tip. As we have discussed, tan is equal to perpendicular upon base. Then as I have already written, A we have taken as theta, and we have discussed that tan is equal to perpendicular upon base, in which our perpendicular is BC, base is AB. Then we can also write tan A, as you have noted, is BC by AB. But what if I give you another value for this? I can write tan A as sin A upon cos A. Let me show you how it's done. Sin A by cos A. Sin A means, as you can see, sin A means perpendicular upon hypotenuse, which is equal to you can say BC by AC, and cos A. Cos A means AB by AC, which as you can write it in this way. And in this you can cancel AC and AC. So we remain with BC is equal to AB. And this is same as the value of tan A. So from these two we derive that tan A equals to sin A divided by cos A. So friends, as we have discussed the value of tan, which is the relation of sine and cos, now we are going to discuss the values of some trigonometric functions with respect to some specific angles. So first angle I am going to take is 0 degree, second angle 30 degree, third angle that I will take is 45 degree, fourth angle 60 degree, and the final angle I am going to take is 90 degree. These 5 angles are the basic angles and the important angles that we are going to study further. The first angle of sine 0 degree, I will write it as 0. Second angle is sine 30 degree. Sine 30 degree, I will write it as 1 by 4 and place it in an under root, which I get is 1 upon by 2. So the final value of sine 30 degree is 1 upon by 2. Then I have another angle sine 45 degree. I will write it as 2 by 4 and put in an under root. 2 by 4 on cancelling I get 1 by 2, which when taking out of root we get 1 by root 2. Then the other angle is 60 degree. 60 degree I will write it as 3 by 4 and place it in an under root. Then the value of root 3 upon by 4 is root 3 by 2. And the final angle sine 90 degree, I write it as 4 upon by 4 under root. On cancelling we get root 1, which is 1, because as you know, anything I mean to say a number 1 in under root gives only 1. Then as now for the value of cos, this is more simpler. As we have written the value of sine from left to right, for cos we write the same values but from right to left. So cos 90 degree is equal to sine 0 degree, which is 0. Then cos 0 degree is equal to sine 90 degree, which is 1. Cos 30 degree is equal to sine 30 degree. Sorry, is equal to sine 60 degree. Friends, noted is sine 60 degree. Root 3 upon by 2. Cos 45 degree is sine 45 degree itself, which means 1 upon by root 2. And cos 60 degree is sine 30 degree, 1 by 2. Then we have tan. Tan means the ratio of sine theta and cos theta. So tan 0 degree is sine 0 degree upon cos 0 degree, which is 0 upon by 1, which gives 0. Then tan 30 degree is 1 by 2 upon root 3 by 2, which is 1 by root 3. Then tan 45 degree is 1 root 2 upon 1 root 2, which means 1. Tan 60 degree is root 3 by 2 upon 1 by 2, which is root 3. And tan 90 degree, note this point, it is 1 by 0, but as you know, any number which has 0 as denominator is written as not defined, and its symbol is this, or you can even say it as infinity. Then the value of cosec 0 degree, it is a reciprocal of sine 0 degree, which is 0. Reciprocal of 0, as I discussed earlier, is infinity, so I'll write again here as not defined, or you can say it as infinity. Then cosec 30 degree is a reciprocal of sine 30 degree. Sine 30 degree is 1 by 2, so we get it as 2. Cosec 45 degree means the reciprocal of sine 45 degree, which is root 2. Then cosec 60 degree means reciprocal of sine 60 degree, which means reciprocal of root 3 by 2, that is 2 by root 3. Then cosec 90 degree means sine 90 degrees reciprocal, which is 1 itself. Then sec 0 degree. Sec 0 degree means reciprocal of cos 0 degree, which means 1. Sec 30 degree, reciprocal of cos 30 degree, 2 root 3. Sec 45 degree, reciprocal of cosec 40, reciprocal of cos 45 degree, which means root 2. Sec 60 degree, reciprocal of cos 60 degree, 2. Sec 90 degree, reciprocal of cos 90 degree. Again 0 comes in denominator, so it's not defined. And cot 0 degree means reciprocal of tan 0 degree, so it's not defined because 0 is coming in denominator. Cot 30 degree, reciprocal of tan 30 degree, root 3. Cot 45 degree, reciprocal of tan 45 degree, which is 1 itself. Cot 60 degree, reciprocal of tan 60 degree, 1 by root 3. And finally cot 90 degree, reciprocal of tan 90 degree. Tan 90 degree is 1 by 0, so cot 90 degree will be 0 by 1. You can write it as 0. And friends, as you can note that sine I have written from 0, 1 by 2, 1 root 2, root 3 by 2, 1. And cos it is opposite. Similarly, as we write cosec from left to right, the same value applies for sec, but it's from right to left. Please note it down as it's important for a trigonometric chapter, because the coming up questions will be based on these angles only, even in a board examinations. If you are studying from a board point of view, then please note it. So friends, so far we have discussed the values of the degrees and we have discussed the values, the ratios, and now I am going to give you some basic identities. Identities, they are not very tough, they are in fact very easy to remember. So first identity is sine square theta plus cos square theta equals 1, which means the value of sine square theta when added to the value of cos square theta equals 1. In this, I'm going to take theta as 30 degree. You can take it at any angle, 60 degree, 45 degree, 90 degree, 0 degree. I take it at 30 degree. Sine 30 degree means 1 by 2. And its square means 1 by 2 whole square. Cos 30 degree means root 3 by 2. Cos square 30 degree means root 3 by 2's whole square, which is equal to 1 by 4 plus 3 by 4, which is equal to 4 by 4. You can get it as 1. This and this RHS, both are equal. So this identity has been proved. Moving on to a second identity, it is sec square theta is equal to 1 plus tan square theta. And friends, one important point to note here is that the theta I am taking for both the trigonometric function, any identity, the theta has to be equal. You can't take sine square 30 degree plus cos square 60 degree equal to 1. You have to take sine square 30 degree and cos square 30 degree. It applies for all the thetas. The thetas have to be equal in each identity. So I'm moving on to the next identity. Sec square theta is equal to 1 plus tan square theta. Here I take theta as 45 degree. So sec theta is root 2. Then the value of sec square theta becomes root 2 whole square. And tan 1 plus tan theta means tan 45 degree. Tan 45 degree is 1, right? So tan 45 degrees square become 1 square. Root 2 square. Square and root cancel. We have 2 is equal to 1 plus 1. So we get 2 equals 2. This identity has also been proved. And then moving to our next identity, that is cosec square theta is equal to 1 plus cot square theta. Cosec square theta. Here I take theta as 60 degree. So cosec 60 degree is 2 upon root 3. So cosec square 60 degree becomes 2 upon by root 3 square. And 1 plus cot square 60 degree is 1 upon by root 3. So cot square 60 degree becomes 1 by root 3 whole square, which is equal to 4 upon by 3 equals 1 plus 1 by 3. 4 by 3 equals to 4 by 3. So we have proved the three identities in the similar ways. As now I am going to write down the three identities. I am discussing these three identities only because these three identities are the basic identities on which you solve your further questions. So the identities, please note it down. First identity is sin square theta plus cos square theta equals 1. Second identity is sec square theta plus sec square theta equals 1 plus tan square theta. And the final identity we have is cosec square theta equals 1 plus cot square theta. So these are three main identities on which you are going to solve your further questions. And now we are going to discuss some questions. So coming up to the first question, we have that, let us take a triangle, a right triangle, A, B, C. So it is given to us that, let us suppose that it is given tan C is equal to this angle I am discussing. Tan C equals, you say, 12 by 5. So as we have discussed, tan C means perpendicular upon base. So tan C is equal to 12 upon by 5. So AB upon BC equals 12 upon by 5. We don't know the value of AC, and they are given that we should find out the value of sin C and cos C. So how do we do it? We have tan C as 12 by 5, which means perpendicular upon base is 12 by 5. So we find hypotenuse using Pythagoras theorem, which is h is equal to p square plus b square under root. So we get h equals under root 12 square plus 5 square. H equals under root 144 plus 25. I am continuing down here. We get h equals root 169. So we get h equals to 13, which means AC is 13. So we have the values: AC is 13, AB is 12, and BC is 5. I hope that you have noted this down. If you have not done so, please pause the video and note it down. Then we have now our three sides are 12, 5, 13. So first, sin C. Sin C we have, sin as we know is perpendicular upon hypotenuse. And in this perpendicular is AB, because sin refers to the side that is opposite to the given theta, and in this we have theta as C. So that opposite side is AB. So sin C will be AB by AC, which means 12 by 13. Then cos C will be BC by AC, because cos refers to the side on which the angle is. So the angle is on BC upon AC. Then it becomes BC is 5 and AC is 13. These are the value of sin C and this is the value of cos C. In this way, we have solved this question in a simple manner. Moving on further, we have our next question. Suppose we are given that in a triangle A, B and C. Okay? Suppose we are given tan square C is equal to, you can say it as 144 by 25, and we are asked to find the value of sec C. How do you find it? Simple, we use the identity tan square C, which means sec square C is equal to 1 plus tan square C. I am writing it out here. Sec square C is equal to 1 plus tan square C, which means sec square C is equal to 1 plus tan square C, we have 144 by 25. 144 by 25. Sec square C is equal to 1 plus, sorry, it's 25 plus 144 by 25. Sec square C will be 169 plus 25. So we get the value of sec C equals 13 by 5. This is the final value. Now before moving on further, let me discuss some basic tips which will help you to solve the further questions. It is related to the degree ratios of some trigonometric functions. So our first function, sine theta. We can write sine theta as cos 90 degree minus theta, and the same applies with cos theta. We can write cos theta as sine 90 degree minus theta. Similarly, we can write tan theta. Please note this one. Tan theta is equal to cot 90 degree minus theta. Then we have cosec theta. Cosec theta, we can write it as sec 90 degree minus theta. Then we can write sec theta as cosec 90 degree minus theta, and we can write cot theta as tan 90 degree minus theta. These are the basic complements of the angle with the changing trigonometric functions. This relation is very useful in the coming up questions. It will prove useful to you. So please note this down. So friends, as we have discussed all the relations, the degrees, now we move further to a question. The question is that if tan A equals 3 by 4, note it, tan A equals 3 by 4, then what is the value of 1 plus sin A cos A and 1 minus sin A cos A? This is a question. So as we know that tan A is equal to perpendicular upon base, we have perpendicular as 3, base as 4. So using Pythagoras theorem, we find out the hypotenuse. We get h equals under root 3 square plus 4 square. So we get h equals under root 9 plus 16. H is equal to root 25. H is equal to 5. So now we have hypotenuse, we have perpendicular, we have base. So 1 plus sin A is equal to perpendicular upon hypotenuse, which means 3 by 5. 1 plus 3 by 5 multiply by cos A is equal to base upon hypotenuse, which is 4 by 5. 1 plus 3 by 5, now multiply by 4 upon by 5, divide 1 minus, again sin is equal to 3 by 5, multiply by cos A, which is 4 by 5. Then by solving we get 5 plus 12 divided by 5 upon 5 minus 12 divided by 5. On cancelling we can cancel the 5. We have 5 plus 12, which is 17, and 5 minus 12 we have is minus 7. So our answer, final answer, is minus 17 by 7. This is the value of 1 plus sin A cos A upon 1 minus sin A cos A. So please note it down so that we can move further before erasing it. So hopefully you have noted it down. Moving to our next question. Our next question is that we are given sine 75 degree plus cos 85 degree. See in this, sine 75 degree plus cos 85 degree, and the question is asking us to make these angles come in the ratio of 0 to 15 degree. We have to make these two angles come in the range of 0 to 15 degree, but both the angles, you can see, are very far away from 15 degree. 3 times 15 degree. This one is almost approximately 4 times 15 degree. Then how do we do it? Using identity, sine theta equals cos 90 degree minus theta, we get sine 75 degree is equal to sine 90 degree minus 75 degree, and cos 85 degree. Using identity, cos theta equals sine 90 degree minus theta, we get, this is not sine, this is cos 90 degree minus 75 degree, and plus sine 90 degree minus 85 degree. So on solving it, 90 degree minus 75 degree, we get cos 15 degree plus sine 5 degree. So with this method, we have made both the angles come in the range of 0 degree to 15 degree. See how simple it is. Now Our next question is, we are given sine 5 degree, sine 10 degree and sine 20 degree. Okay, and all this is multiplied by sec 85 degree, sec 80 degree and sec 70 degree. We have to find the value of this equation. So let's see how it's done. Sine 5 degree, it remains sine 5 degree. Sine 10 degree will be written as same. Sine 20 degree will also be written as same. There will be no changes in these three values. Now coming to sec point of view, we can write sec theta as cosec 90 degree minus theta. So I'm writing as cosec 90 degree minus 85 degree. Then I can write sec 80 degree as cosec 90 degree minus 80 degree and sec 70 degree as cosec 90 degree minus 70 degree. Okay, and all these are multiplied with each other. So how do I get the answer? I can write this as sine 5 degree, sine 10 degree, sine 20 degree and this as cosec 5 degree, cosec 10 degree and finally cosec 20 degree. After this I can write cosec, as you know, is the reciprocal of sine, so I can write cosec 5 degree as 1 by sine 5 degree. Then again I can write cosec 10 degree as 1 by sine 10 degree and finally cosec 20 degree as 1 by sine 20 degree. Then I can cancel sine 5 degree and sine 5 degree, sine 10 degree and sine 10 degree and again sine 20 degree and sine 20 degree. On cancelling all these I get the final answer as 1. So this equation has its answer as 1. Now friends, we have the question, if tan a plus b is equal to root 3 and tan a minus b is equal to 1 upon by root 3, find the value of a and b, given that the condition is a and b are greater than 0 but less than 90 degree. So on solving we get tan a plus b is equal to root 3, which means tan a plus b equals tan 60 degree. I have proven it in the table that root 3 is equal to tan 60 degree. Now we can reduce tan from both the sides, so we get a plus b equals 60 degree. This is our first equation. Similarly, tan a minus b, we can write tan a minus b is equal to tan 60 degree. Sorry, it's tan 30 degree. Why 30 degree? Because tan 30 degree is equal to 1 upon by root 3. Again reducing tan, we get a minus b is equal to 30 degree. This is our second equation. So from first and from second we can reduce b and we get 2a equals 90 degree. which implies that the value of A equals 45 degree. Now if we put the value of A in equation 1, we get 45 degree plus B equals 60 degree, which means B is equal to 15 degree. So we have the values A is equal to 45 degree and B is equal to 15 degree. This is the solution of the given question. I'll explain it again. We have written tan 60 degree here because root 3 is equal to tan 60 degree. I have proven it in the table, and tan 30 degree is equal to 1 upon by root 3. This has been also proven in the table. So A plus B and A minus B, on adding we can cut plus B and minus B. So we have A, 2 A's are there, so we have written 2A, and 60 degree plus 30 degree is equal to 90 degree. So A is equal to 90 degree upon by 2, which I have written as 45 degree. You can see here. And then 45 degree plus B is equal to 60 degree from equation 1. I have kept the value of A in equation 1. Then we have B is equal to 60 degree minus 45 degree, which is 15 degree. So our final values are A is equal to 45 degree, B is equal to 15 degree. And then now moving on to our next question. Our next question is that we have to evaluate the value of 2 tan 30 degree divided by 1 minus tan square 30 degree. So as you know, the value of 2 tan 30 degree is, we take only tan 30 degree. Tan 30 degree is 1 by root 3. So 2 into 1 upon by root 3 divided by 1 minus tan square 30 degree. Tan 30 degree is 1 upon by root 3. So tan square 30 degree becomes 1 upon by root 3 whole square, which is equal to 2 root 3 divided by 1 minus 1 by 3, which gives 2 root 3 divided by 3 minus 1 upon 3, which is equal to 2 root 3 by 2 by 3. On cross multiplication, as you know, second and third, first and fourth, we get 2 multiply by 3 upon root 3 multiply by 2. On cancelling, we get the value as root 3. This is our final solution.